Question 3, we have two smooth spheres of masses m and 2m. They're colliding obliquely, and it's along the y-axis. This line is center, so no change in the j. So beforehand we have 6i plus j and minus 2i minus 5j. So afterwards we're going to have ai plus j, and we're going to have bi minus 5j, so no change in the j. So after the collision, the lighter sphere moves along the j-axis. Okay, the lighter one is the top one, so therefore a is equal to 0 if it's moving along the j-axis. So it makes this question quite easy. So we'll call this 1m. We'll use the 1 and the 2. So we can set up our equations. 1 times 6 plus 2 times minus 2 is equal to 1 times a is going to be 0 plus 2 times b. So really quickly we can get b. 2b is equal to 6 minus 4, which is 2. So b is equal to 1. So we're asked for the velocity of the heavier sphere after impact. So it's going to be 1i minus 5j. And then the coefficient of restitution, we can say a minus b over 6 minus minus 2 is going to be equal to minus e. So a minus b is just 0 minus 1 over 8 being equal to minus e. So e is equal to 1 over 8. And that's the end of this question. So on to question 4. In question 4, we have a sphere of mass 2m moving with velocity 5i plus 5j colliding obliquely with a sphere of mass m, which is at rest. So we have 2m, m. We have 5i plus 5j, which is going to become ai plus 5j. Second sphere at rest, so 0i plus 0j, which is going to become bi plus 0j. So we apply our equations here. So allow the second one to be a 1. So we're going to have 2 times 5 plus 1 times 0 is equal to 2 times a plus 1 times b. So we get 2a plus b is equal to 10. Secondly, we're going to get a minus b over 5 minus 0 equals minus e, so minus 1 over 2. So we get 2a minus 2b is equal to minus 5. And we have 2a plus b, so we get 4a plus 2b is equal to 20. So we're going to get 6a equals 15. And just write down what you're doing. You're bringing this equation up and you're multiplying it by 2. 6a is equal to 15, so a is equal to 2.5. If a is equal to 2.5, we would get 5 plus b is equal to 10, so b is equal to 5. So we're asked for the velocities. So the velocities become ai plus 5j, which is 2.5i plus 5j, maybe label them P and Q, P and Q, and that's 2.5, and then the second one Q becomes BI, which is 5i plus 0j. Second part, we're asked for the impulse imparted to each sphere during impact. So we take P first for impulse. Take P, just change them to red. So the impulse imparted on P is equal to mv minus mu. So we're going to have 2. Now we can write in terms of m if you want here. We're just doing everything in terms of m. You can bring the m back in if you want, but you know what we're doing here. Just making it a little bit shorter. 2 times ai plus 5j, so 2.5i plus 5j. And then minus 2 times what we started with, which was the 5i plus 5j. So we're going to get 5i plus 10j minus 10i minus 10j. So we're going to get minus 5i Newton seconds. And if we take q, we should get plus 5i. Check q, the impulse. It's going to be its mass, which was 1, times what it ended up with, which was the 5i plus 0j. Then minus 1 by what it started at, which was 0. So we're going to get 5i Newton seconds, which is what we said. Then we're asked for the percentage loss in kinetic energy. So let's come down here a bit. Percentage loss in kinetic energy, just so we can see everything that's going on. So we've got a half mu squared. So what do we start with? We start with a half times 2 times, this is going to be square root of 5 squared plus 5 squared, which is equal to root 50 for its velocity. So root 50 to be squared, which is just going to give 50. And then afterwards, we're going to have a half, because this one was 0, there's nothing happening. So we're going to have a half 2 by the magnitude of this. So the square root of 2.5 squared plus 5 squared. So that's going to give the square root of 5 over 2 squared is 25 over 4 plus 25. So the square root of 6.25, 31.25. So the square root of 31.25, obviously to be squared is just going to be 31.25. So we're just going to get 31.25, and then we have the second one, plus a half 1 by 5 squared, which is half of 25, which is plus 12.5, 43.75. So the loss in kinetic energy, or we asked for percentage loss. Percentage loss in kinetic energy is, we lost 6.25, and we started at 50, and if we multiply that by 100, we're just going to multiply 6.25 by 2 to get 12.5% loss in kinetic energy. In the last part, we can find it. We're asked for the angle through which the heavier mass is deflected. So this 2m mass here. So it's traveling at 5i plus 5j, so that's the inverse tan of 1, so it's kind of traveling in this direction. And then it ends up traveling at 2.5, then we get for a 2.5, 2.5i plus 5j, so not as steep. So let's say like this, so we want the angle to which it's deflected. So when we think about the angle between two lines, we should be able to get our answer here. So we need the slopes of these lines. So initially P, we have the inverse tan of 5, or we have the tan of the angle is equal to 5 over 5, which is equal to 1. Then we have the tan of the angle, we call them A and B. The tan of the angle, we have 5 over 2.5, 5 over the 2.5. So that's equal to 2. So tan of theta, the angle between two lines formula, is equal to plus or minus m1 minus m2 over 1 plus m1 m2. So filling that in, we're going to get 1 minus 2, or 2 minus 1. We do it the other way around, maybe just do the 2 minus 1, make it positive. 2 minus 1 over 1 plus 2 times 1, which is equal to 1 over 3. And the inverse tan, we're getting the acute angle, not the whole angle. The inverse tan of 1 over 3 gives our angle B, or our deflected angle, to be equal to 18.43 degrees.